So in this revisiting irrational numbers, we'll prove that the given numbers are irrational. There are three different models. The first one is they'll ask to prove that root 2, root 3, root 5, root 7 or root 8 etc. are irrational numbers. This is one model. The next one is sum or difference of numbers proved as irrational. Prove that 2 plus root 3 or 2 minus root 3, these are irrational numbers. And the next case is prove that 1 by root 7 or 2 root 7 a product of these numbers. And the next one is prove that mainly 3 here only, or root 2 minus or plus root 3 is an irrational number. These are the different types we have in 10th standard level. So in this topic, we are going to prove these are irrational numbers. So out of these are very important. Prove that root 2, root 3, root 5 or root 7 are irrational numbers. Based on that, these also we can prove easily whether they are irrational numbers. Irrational numbers only, we can prove it easily. So let us see the first one. Root 2, root 3, in examples they solved. So let us see root 5, prove that root 5 is an irrational number. This is given in the first question, exercise 1.3. Only one question. If you learn this root 5 is a irrational number, prove that. So you can easily prove root 2, root 3, root 5, root 7, root 8, any number which is irrational can be easily proved. So let us see the solution. The process is same, even the steps also same. After complete this solution, in place of 5, if you replace 2, root 2 as irrational number, like that we can easily prove that. So see this one. First, let us assume that here we'll use the contradiction method, indirect method. Root 5 is a rational number. So when we assume that root 5 is rational number, if our assumption is wrong, then we should accept that root 5 is irrational number. Isn't it?
Yes, sir.
When root 5 is a rational number, we know that the general form of a rational number is in the form of p by q. So root 5, we can write it as p by q, where q not equal to 0. And pq are co-primes. This is very important. PQ are co-primes in the sense the common factor of P and Q is 1 only, not other than that. So this also can be expressed as HCF of PQ equal to 1. Any one you can write, this one or this one. So when we assume this as a contradiction, root 5 is a rational number, so we will get at last the HCF of PQ is other than 1. But as per the definition, HCF of PQ must be 1. If it is other than 1, then our assumption is wrong. Do you understand it?
Yes, sir.
Yes, sir.
If you understand this step, you can easily get this result. Now let us see that. So when root 5 equal to P by Q, then cross multiply it to prove that P and Q have the common factor other than 5, we can cross multiply this 5Q equal to P. Now squaring on both sides. Then we get this result is root 5 times of Q whole square equal to P square. Then root 5 square is 5 into Q square equal to P square. 5Q square equal to P square. Then we can write 5 divides P square. For example, let us take 5 into 5. What you'll get now? 5 into 5.
25.
25.
25.
Suppose P square, take it as 25. Q square value is considered as 5. So 5 into Q square equal to P square, right?
Yes, sir.
Now, in this case, 5 divides 25 or not?
Yes, sir.
Divides in the
Yes,
sense,
sir.
so when we divide 25 by 5, the remainder must be 0. So when 5 divides 25, that means 5 divides P square, isn't it?
Yes, sir.
So using the same concept, we'll write here 5 divides P square. When 5 divides P square, when P square is 25, now what is P value? When P square is 25, what is P value?
So 5.
5.
So when 5 divides P square, 5 divides 25, is 5 divides 5 or not?
Yes, sir.
When 5 divides P square, then 5 divides P or not?
Sir, it will divide.
That's it.
Divide, sir.
You understand? That's it, ma. So you need not write this step, ma. This is for make you to understand. That's it. So we can write 5 divides P. Now take this as equation 1 and take the other one is equation 2. That's it. When 5 divides 5, so how do we write this, ma? Can we write this as 5 ones are 5?
Yes, sir.
So suppose 5 divides 5, 5 ones are, we write it. Suppose 5 divides 10, how can we express it?
So 5 into 2 is equal
5
to 10.
2.
That's it. Suppose 5 divides 15, 5 3 times. So 5
5
divides,
sir. 5 into 3.
yes, yes. 5 divides P we have taken in second equation. So that only we can write this as 5 divides, when it is P, we can write P equal to 5K, where K is any constant. So you should understand this one. If you cannot understand, let you ask me, then we'll discuss it. If you understand this one, that's it over. We'll get it easily. So 5, this is P in this case. This is P in this case. This is P. So 5 is fixed. So 5 divides P. 5 divides P. 5 divides P. So 5 divides P. We can write it as 5 into some value. 5 into some value. 5 into some value. That some value I am going to consider as K. So can we write 5 into K equal to P or not?
Yes, sir. Yes, sir.
That's it. If
Yes,
you
sir.
understood this, that's it. The solution is over. You'll get it easily. Now, when 5 divides P, we are going to write P equal to 5K. Right now? Next. Where K is an integer. Now again, we got P is 5 divides P means 5 is a factor of P. Now we should check out the factor of 5 is a factor of Q or not. To verify that, again squaring on both sides. So this is P square equal to 5K whole square. So P square equal to 25K square. See, from the equation 1, can we write P square as 5Q square? See, this is the equation 1. Can we
Yes,
write
sir.
P square as 5Q
Yes,
square?
sir.
So 5Q square, write it, equal to 25K square. This is 5 ones are 5 5s are cancelled. So this is Q square equal to 5K square. See this one, equation 1, P square equal to 5Q square means 5 divides P square. When Q square equal to 5 square means 5K square means, what can you say about that? 5 divides Q square. When 5 divides Q square, so 5 divides Q.
Q.
Using these 3 steps only, we can write these 3 steps. So the examples already we have taken. Next, from these equations, let us take this is equation 3. What do you observe from equation 2 and 3? Here 5 divides P, here 5 divides Q. That means, what is the common factor of P and Q, ma?
5.
Yes. From equation 2 and 3, 5 is the common factor of P and Q. If 5 is a common factor of P and Q, as per the definition, what is the common factor must be there?
Sir, 1.
1 only.
1.
So is this wrong or not?
Sir, our absorption is wrong.
Yes, that's it.
Wrong.
So here we write, this is a contradiction. This is a contradiction to the fact that P and Q are co-primes. Or you can write it, it contradicts our assumption, right? Therefore, when it is a contradiction, we should accept the truth. Root 5 is
It's irrational.
an irrational. That's it. And it's proved. Now, if you have any doubt in this solution, you ask me. We'll discuss it. Is it clear to you all?
Yes, sir.
Right. So if it is clear, instead of 5 from the solution from the beginning till the end, the process is same for all the remaining numbers, either root 2, root 3, root 5, root 7, root 8, root 10, whatever it is. Suppose in place of 5, if you replace by 2 from the beginning to the end, you can easily prove that root 2 is an irrational number. In place of 5, if you replace by 3, so root 3 is an irrational number. In place of 5, if you replace by 7, you can prove it as root 7 is an irrational number. The process is same. You need not change any values, any statement. You just change only the numerical value as per the given statement. Is it clear?
Yes, sir.
So I hope so you can complete these type of questions.
Yes, sir.
So the homework is
Sir.
you should prove that root 2, root 3, root 7 are irrational numbers using the same model,
Yes, sir.
right? Two marks question directly we can proceed, or else in the question itself, in the question paper, if you find it, if root 5 is an irrational number, then prove that 3 plus 2 root 5 is irrational. If the question is asked like this, here the condition is already given. If root 5 is an irrational, in the question itself, if it is mentioned if root 5 is an irrational number, you need not prove that root 5 is an irrational number. Directly, you can prove that 3 plus 2 root 5 is irrational, right? Do you understand it?
Yes, sir.
Sir.
If it is not mentioned in the question, root 5 is an irrational number. If they are asked to prove, like this question is given, prove that 3 plus root 2 root 5 is irrational. Then you have to prove these two statements also. First, you have to prove that if it is root 5 is given, root 5 is irrational. If root 3 is given, root 3 is irrational. First, we have to prove that root 5 is an irrational, because it is not given is irrational. After prove that root 5 is an irrational number, then we have to prove that 3 plus 2 root 5 is also irrational. Is it clear, ma?
Yes, sir. Yes, sir.
Yes, sir.
Right. Now first let us prove that root 5 is a rational number. Now in this case, we have proved that root 5 is an irrational number, as we discussed in the first question. Now, still we have to continue this part. I will consider that let let us assume that 3 plus 2 root 5 is rational, or a rational number. Let us assume that 3 plus 2 root 5 is a rational number. If it is a rational number, we can write this as 3 plus 2 root 5 equal to p by q. Already we used, right? So we'll use another letters, a by b, where b not equal to 0 and HCF of ab is 1. Then we can write this as 2 root 5. Root 5, root 3, root 7, whatever it is given. The irrational number write one side. The remaining all values transpose to other side. So this is a by b plus p plus 3 transpose this side, minus 3. Then root 5 equal to, find the LCM, this is a minus 3b by b. This into 2 transpose this side, divide 2. Clear, ma? I found here
Yes, sir.
LCM. That's it. So if you see the right side part, is it a rational or not? As AB are integers, as per the definition of rational number, AB are integers. So here, a numerator and denominator also consists of integers, so that it is a rational number. When this is a rational number, root 5 is also rational number. Isn't it? Do you understand it, ma'am?
Sir, how is that rational number, sir?
Right. So here one more is you need not take LCM also, direct also we can write. One by two, write it down. How it is a rational number? Suppose substitute this half of A and B considers integers. So I am going to take this is 6 and B is 2 minus 3. 1 by 2, 6 by 2 is 3 minus 3. Is 1 by 2 times of 0. Is it? So the result is 0. Is it a rational number or not? 0 is a rational number
Yes,
or
sir.
not?
Yes, sir.
So the right side part we are getting it as rational number, this part. Isn't it? When it is a rational number, right side part is rational number.
Yes.
So left side part is also rational number. So that we got the result is root 5 is rational. Therefore, root 5 is a rational number. But we know that already we proved, right? We know that root 5 is an irrational number. Therefore, our assumption is, it contradicts our assumption, right? It contradicts our assumption. So our assumption is wrong, so that we should accept it. Root 5 is, therefore, root 5 is an irrational. When root 5 is an irrational, sum of rational and irrational is always irrational. Therefore, 3 plus 2 root 5 is an irrational. That's it. Do you understand it?
Yes, sir.
Yes, sir.
If anybody did not understand, ask me. We'll discuss it once again.
Sir.
Is it clear, ma?
Sir. That it is rational number.
Yes, ma. A and B I have taken 6 and 2, right?
If we take any other value, it can be solved and proved as rational number, sir.
Yes, ma. You can take any value, but A and B must be integers as per the definition of rational number. A by B is rational number where B not equal to 0 and A, B are integers. You can take any integer. Suppose instead of this, now we are going to take half. A is 7, B is 3. So it may be sometimes may get irrational. So we'll take 2, right? Minus 3 is fixed. So half of this is 3.5, right? Minus 3. So this is half of 0.5. 0.5 is 1 by 2 only. So the result is 1 by 4. Is it a rational number or not?
Yes, sir.
That's it. We should choose the AB values as integers, which gives the rational. Mostly we'll get, if we take AB or integers, we'll get rational numbers only.
Yes, sir.
Yes, sir.
Right. Any other doubts?
No, sir.
See
The
that if we take any indices, can we get a rational number? Sometimes, based on the denominator, we may get irrational number also in place of 6 by 2. But as we assume that 3 plus 2 root 5 is a rational number, if it is a rational number, it is already rational number. So a by b also must be a rational number. What are the indices you are going to select? You must choose the values which gives the rational number. When a by b is a rational number minus 3 is also rational number, we know that. Rational number minus rational number gives a rational number. Is it clear, ma?
yes,
Yes,
sir.
sir.
That's it.